Welcome back to the deep dive. Today we're going really micro, diving into something you flagged as essential in industrial biotech.
Yeah, we're talking about cell membranes.
Exactly, cell membranes. We're going to try to unpack why this seemingly simple barrier, controlling what goes in and out of a cell, is such a big deal when it comes to making bio-based products.
Right. It's easy to picture a cell like it's just a simple container.
Right, a little bag holding all the stuff.
But the membrane is so much more than that. It's really this incredibly sophisticated gatekeeper, carefully controlling what can enter and leave.
So not just any old bouncer. Right?
No. It's very precise. And in industrial biotech, that level of control is critical for making the whole process work. I mean, we're talking about feeding the cells the substrates they need and then getting those valuable products out.
So it's like optimizing the whole supply chain, but on a microscopic level.
Exactly. And on top of that, it also helps cells get rid of anything that could harm them.
Okay, so it's a three-way system. Ingredients in, products out, and trash out.
Yeah, that's a good way to put it.
So let's break this down. Why is this ability to kind of tune a cell's permeability, why is that so important for making these bioprocesses better? What's the big deal?
Well, I mean, it really all comes down to efficiency, like you said, optimizing the entire process.
Okay.
And that plays out at different stages. So first, you've got to think about the uptake of the substrate.
Okay, so that's like the raw materials, right? The stuff the cells use to make what we want.
Yeah, exactly. Sugars, other nutrients.
Mhm.
The cells need those to function and produce, but the membrane's permeability determines how easily they can actually get those materials in.
Okay, so if the membrane's not very permeable, the cell's kind of
Yeah,
stuck.
exactly. It's like, trying to get all the ingredients for a big feast through a tiny little door.
And that's going to slow things down.
It's going to slow everything down, yeah.
So, all right, so we get the raw materials in, the cell does its magic, and then what? How does permeability come into play once the product is made?
Well, that's the next big step, right?
Yeah.
Product secretion.
Right.
So we've got to get those valuable compounds out of the cell.
Right.
But if the membrane is too restrictive, too tight, those products can build up inside and actually even mess with the cell's ability to produce more.
Oh, so it's like a traffic jam on the production line.
Yeah, exactly.
Okay, so we want things flowing smoothly both ways.
Precisely.
Now, the source also mentions getting rid of what it calls inhibitory compounds.
Hmm.
Why is that a permeability issue too?
So as cells are growing and producing, they inevitably generate, waste products or other stuff that can actually slow them down.
Okay, so their own internal, like, clutter.
Yeah, exactly. It can build up and become toxic, inhibiting their own growth and production.
Mm-hmm.
So by tweaking the membrane's permeability, we can basically help them pump out those inhibitory compounds more effectively.
So keep the factory clean.
Keep the factory clean.
So it's like a constant, like, trash removal service going on. Okay, so by controlling what gets in and out, we can basically turn up the efficiency dial for the whole process.
Right. More food in, more product out, less waste buildup.
So we can get more of what we want in less time.
Precisely. It's really about fine-tuning those conditions for the cells to thrive and be productive.
Now, the source mentioned something interesting here. It talks about methods for changing membrane permeability.
Yeah.
But it doesn't really go into detail about how that's actually done.
Yeah, it kind of just touches on it like it's this important area,
It's like, hey, we can do this, but not exactly the how.
Right, exactly.
But it does make it clear that scientists and engineers have come up with different techniques to change permeability.
Right. And there are quite a few different approaches, actually.
Like what?
Well, it could be things like chemical treatments that modify the membrane structure, or even genetic modifications to give the cell specific transporter proteins.
Oh, so basically creating dedicated channels for certain molecules to pass through.
Yeah, exactly. And the goal is to make those adjustments targeted.
Okay, so not just making the membrane generally more or less permeable, but actually controlling what specific substances can go through.
Precisely.
And when.
Yeah.
Now, the source also briefly touches on applications without giving us specific examples.
Yeah.
But what kind of potential are we talking about here? What could this kind of control enable us to do?
I mean, the possibilities are really quite amazing.
Yeah.
Imagine, engineering yeast that could rapidly absorb sugars and then, almost effortlessly secrete ethanol.
So basically supercharging biofuel production.
Exactly. And potentially making it much more cost effective.
Wow.
Or, think about bacteria that are modified to efficiently release a complex pharmaceutical compound.
So we could simplify the whole purification process.
Exactly. And those are just a couple of examples. This ability to fine-tune commuability has implications across all sorts of sectors.
Wow, from medicine to sustainable materials, you name it.
Exactly.
So it's really a fundamental tool in the industrial biotech toolbox.
Absolutely.
Okay, so to kind of wrap things up, the big takeaway here is that modifying a cell's membrane, its permeability, that's a powerful way to impact how efficiently we can make all kinds of valuable things using biology, right?
Yeah, definitely. And I think what's really cool here is how, all these processes are interconnected.
What do you mean?
Well, it's not just about optimizing one step in isolation.
Hmm.
It's about orchestrating the whole flow.
Right, like we said, substrates in, products out, waste out.
Yeah.
It's a delicate balance.
It is. It is. And that actually makes me wonder, when we're manipulating permeability for one specific substance,
Hmm.
are there trade-offs? Could we be unintentionally disrupting other important
Oh,
processes?
that's a really good point.
Yeah,
It's like tweaking one part of a complex machine.
right.
You might accidentally throw something else off.
Exactly. And with something as fundamental as a cell membrane, the effects could be quite far-reaching.
Definitely something to consider.
Yeah.
This whole deep dive into cell membrane permeability has given me a lot to think about. I mean, considering how essential this barrier is to all life, not just in industrial settings.
Right.
What other unexpected applications might we discover as we learn to manipulate it? I mean, could we move beyond just making existing processes better
Yeah.
and maybe design entirely new ways of producing things, new biological platforms?
Hmm. Now that's something to ponder.
It is. It is. Thanks for joining us on the deep dive. We'll see you next time.